Alright, welcome back. So, until now we work with nodes, topics, services, and launch files. But none of that describes a physical robot. We don't yet have a geometry, a structure, links, joints, kinematics. Now we move into robot modeling. In ROS2, robots are described using URDF files, the Unified Robot Description Format. This is the standard way to define a robot's structure. So an URDF file is an XML file that describes links, joints, visual geometry, collision geometry, inertial properties. Every robot in ROS2 is built using links connected by joints. Think of it as a tree structure. A ring represents a single rigid body. It contains a visual element, a collision element, or inertial properties. Visual is what you see in RVs. Collision is simplified geometry for physics. Inertial defines mass and inertia. URDF supports four basic geometry types. It supports a box type of geometry, a cylinder, a sphere, and a mesh. For learning, we use simple primitive shapes. They're easier to debug. We also have materials that defines color in visualization. RGBA means red, green, blue, and we also have alpha for transparency. Alpha at 1 will be a fully visible color. So the joints connect links. They define a parent link, a child link, an axis of motion, and the movement limits. And URDF forms a tree structure. This must be always be a single root link. Normally, with this type of joints, we can define almost every robot in the industry. So, using a join and these types of join types, you can almost create an URDF file that describes any robot that we have on the market. So let's start with an example. We will create a dedicated description package structure to build the three joint arm robot. So we start with this command to create the folder and the URDF file. Now we create the robot description file. So we copy paste this URDF file that we have. Okay, let's see what's inside this file. So this file always starts with this that describes an XML type of file. So here we have the name of the robot. Here we have the materials that we put it here. So we have reusable materials at the top to avoid duplication. We have the world link is a fixed reference frame. Everything will be attached to it. So here we have the base link. So the base link uh, is a cylinder fixed to the wall. It acts as a robot foundation. After this, we have the shoulder link. So the shoulder link is a revolute joint connecting the base and the shoulder, allows rotation along one axis. Here we have the elbow link. So it's another revolute joint that connects the shoulder and the elbow. And here we have the wrist link. So it rotates around a different axis, gives orientation, capability at the end. And at the end we have the effector. Is a fixed joint representing the tool or gripper that we can use as our organ terminal or to attach any type of actuator. So here we will need to visualize the robot. So we need to launch three nodes: robot state publisher, join state publisher GUI, and RVS2. So this is what it does, this launch file. So first we create this launch file. We can copy this using Nano or another code editor. So we need to update the CMake list. So we'll add this line of code here, and we'll update also the package.xml. Okay, so we can also install the dependencies if we didn't do it before. And we can build and run the launch file. Okay, so we had an error that he didn't find the config file. So you either create the folder config or you remove it. So that's why I did in the CMake list. I removed the config that was here. You can also create the folder. It's the same. So after that we can rebuild. Okay, so no error. It's perfect. So here we can launch to see our robot. So here we can close this. So we start by adding the robot model here. After that, we set the description topic to robot description. And finally, we set the fixed frame to world. So here we have our robot that we have described in our URDF file. With this type of file, URDF, you can create like any robot that you want. You can import from internet like any model, like a Tesla robot, six arm, a drone. So it's really into you to understand how to describe a robot, to respect the structure, and to modelize or to simulate any robot that you want. You have also this type of check tools that can help you to check if your URDF file description is good and contains any error. So in this video, you have learned how URDF describes a robot structure, how links are rigid bodies, joints connect links, visual versus collision versus inertial, how to visualize in RVIs, and how TF3 is generated.